Hello everybody, today we'll be going over the defrost timer from Paragon. This is a 240 volt time clock instead of 120 volt. Here is the schematic of it, but let's just go over the very basics of the wiring. So this can get a little confusing if you're not familiar with all this stuff. So I have the time clock out of the case here, and this is, remember, 240 volts. So L1 is going to 1 here, and 1 to 2 is jumped, and 2 is always going to 4, normally closed. Now if you look here, 1, 2, and 4, this is going to the evaporator coil and to the thermostat and solenoid valve. So when a thermostat is satisfied, when it's achieved this temperature, then the solenoid valve will close, closing the refrigerant to the circuit, and only the evaporator fan will run. And then once that thermostat gets up in temperature again, then it will close and operate that valve, so on and so forth. So that is the freezing cycle, because you only want the fan to blow out cold air. But so before I get too into that too about the cold air, let's just go back to this. So yeah, 120 volts, 1 to 2, 4, it's leaving out of 4. I see 4 is going to the evaporator fan into the thermostat, okay? And that is it, okay? And then you have your neutral. So your neutral here isn't neutral for 240 volt, okay? Now if this is 120 volt, yeah, sure, okay. 120 volt, this will be neutral. But when you have 240 volt, you do not need neutral. So this neutral is really L2. So let's pretend this is L2, okay? So now you have your other 120 volts feeding, and it's feeding the solenoid valve, okay? So your solenoid valve is for 240 volts. You don't need a neutral when you only have 240 volts. So here, when you have 120 come out of 4, and then it goes to the thermostat, okay? If that thermostat is open, that solenoid valve will not open. So if this thermostat is satisfied, then the solenoid valve will not be on. But if the thermostat needs more load, the solenoid valve will open. So this thermostat just opens and closes to 120 volts, and this neutral is always providing the 120 volts to it, okay? You can look at this diagram either way, 120 or 240 volt. It's just one has a neutral and one doesn't, okay? The loads for 240 don't have a neutral. The loads for 120 need a neutral, obviously, okay? So some loads are like the defrost solenoid, the clock motor, the solenoid valve here, okay, the evaporator fan, the defrost heaters. These are all loads. The difference is 120 volt needs a neutral, and the 240 volt loads need no neutral. So 120 volt loads need a neutral, 240 volt loads do not need a neutral. That is the only difference, okay? So this N here, okay, this N is always getting 120, and this L1's getting 120, okay? So here's what happens when we go into defrost. So this is an example of the system and just regular freezing, okay? Now this is the unit and defrost, okay? So once the time clock's initiated here, so here it initiates by these pins, okay? So I'm gonna speed this up, I'm gonna move this clock, okay? So these pins, you can take these pins out and you can move them to anywhere. So it's in 2-hour increments only. So if you want your thing to go to 4 p.m. instead of 6 p.m., or I'm sorry, this is 6 a.m., 4 a.m., you can initiate that. You can take these out. And they also provide 2 more pins you can take out of here. You can take these pins out and you can hook them up here. How it works is, so if you just move it, okay? So watch this, okay? So you see this and you see this. So as soon as that gets close to initiate, you'll hear a little click. You hear it? And you see it moving? Now what that did was it activated 1 to 3. So usually normally closed is 2 to 4, okay? But now what we did was, now we just initiated defrost. Now it's going 1 to 3, and it's these set of contacts here, okay? These contacts are what initiates it from 1 to 3. So these contacts move when it goes in a defrost cycle. So let's go like this, okay? Let's go like this. So we're gonna kill the power, okay? That's the defrost solenoid. We'll get into that in a sec. So we killed the power, okay? So now we're out of defrost mode, okay? So before we get back into defrost mode, let's do this. So before I get too far into it, so I'm right about to go into defrost. It's noon, okay? It's 12 o'clock in the afternoon, okay? So I'm initiating it. Now let's go on the back. I'm still initiating it. So right now I am moving the time clock. Just watch those set of contacts there. You see how it moved? This slide bar moves, okay? And that's based off the time that you have it set to. So when that slide moves, you're going 1 to 3 now. But then once that defrost is achieved based off of time, or based off of the DTFD, then the slide will go back to 4, which is normally closed. 3 is normally open, okay? So let's get into, before we get into the DTFD and the defrost solenoid, let's talk about the minute setting. So you can adjust, so let's say for instance right now we're in defrost, right? We're in defrost at noon because we're at noon, okay? So right now the time clock's at 12 and we're in defrost. You can set how long you want that to be in defrost for. So right now it's set to 40 minutes, all right? So if you push this piece of shit back, okay? If you push it back like that, you can adjust the minutes like that, okay? So now we're at 80 minutes, okay? So you just have to push this thing back, because you see how it sits like that, right? You can't adjust the minutes of the defrost. But if you go if you push it back and then move it, you can now adjust the minutes of how long you want the defrost to be. Usually it comes to 60 minutes. I'm sorry, 40. Usually comes to 40 minutes, but just you might have to adjust it for whatever needs you need for your freezer. You know, if your freezer's not if it needs longer time to defrost, you know, you might have to adjust the minutes or whatever. But usually they come to 40 minutes. This is a pretty just default time clock. It's, you know, nothing was changed about it, so we're at 40 there, okay? So now, let's talk about the DTFD, the defrost termination fan delay. Okay, I don't have a picture on me of one, but you can look it up. It's like a little black circle. Okay, it looks like a what do you call them? It looks like a limit switch in a way, but it has 3 wires going to it. Okay, and so for this, so if this is a 240 volt time clock, okay, so you always have power going to neutral, okay, and you always have power at R. Now this is for 240 volt, okay. So what happens is once this unit's in defrost, okay, the defrost heaters are always on, okay. Now, once the defrost termination fan delay, or DTFD, senses 55 degrees and higher, R to brown is going to close, and that 120 volts from N to N to R to brown to X goes up to the defrost solenoid, and that disengages the slide bar back to 4 and kills the defrost heaters. So that defrost solenoid will kill the slide bar and move the slide from 3 to 4 to go back to the freeze cycle, okay? That's all what it does. So if you look, we're about to be in a freeze cycle. I'm in a defrost cycle. So right now we're in a defrost cycle, okay? We are currently in a defrost cycle. And here is the defrost solenoid, okay? Now, if this defrost solenoid always has power and defrost on the one side. But once R and brown are connected, that 120 volts from L2, which is called N, but since it's 240, we should call it L2. Since L2 is going to R, always going to R, and the DTFD senses 55 degrees because of the defrost heaters, defrosting the ice off. Now that is 55, it's going to cause that switch to close. And now the defrost solenoid is being powered from brown, is traveling to X to the defrost solenoid, and once that defrost solenoid is powered from both legs, it's going to go like this. You hear that click? That's what it does. It disengaged, and now the contacts are now back to 2 and 4. So now the contacts, now when this engages, and now it becomes like this again, and 4 is closed to 2 and 4. So let's do that again in case I confused you. So we're gonna go to defrost again. Okay. We're now in defrost. Okay. Now this DTFD is gonna want to send power. It's going to want to send power to the defrost solenoid. Okay, and once the defrost solenoid is energized from both legs, now I'm gonna hit this button here and just watch these contacts. Okay, you're gonna see it switch from 3 to 4. See how it switched there? So that is what the defrost solenoid does. It kills the defrost once the temperature of 55 is achieved. And then once the defrost solenoid moves the slide bar, it's going to start the freeze cycle again. Here's the freeze cycle, okay. And it's not going to, so once you have that temperature of 55 achieved and it kills the defrost, your evaporator fan is not going to come on until it hits 25 degrees Fahrenheit. Because how are you going to freeze a room and blow cold air when that cold air is 55 degrees or 50 degrees even, or 45 or 40? You're trying to freeze that room. You're not trying to blow air warmer than typically 32. So if you look, that is why if you have 120 volts coming to neutral always, or to L2, and it's feeding R, it will complete the circuit. I'm sorry, this isn't 120. This will feed the evaporator fan, because the evaporator fan has the one side of L1, but it needs that second side of L2 to energize the fan. So the DTFD will energize the fan once the temperature 25 is achieved, okay? And then this fan will stay on as long as it's 25 degrees or lower, okay? Now here's the standstill part, okay? Let's go to the standstill. So you see how we're like in between. So let's say that the temperature is like 40 degrees right now, okay? Obviously, the fan's not going to come on, okay? The fan's not going to come on until this gets to 25, and that's when this will close. Then once that closes, and then the fans will come on. But regardless, 4 is always feeding the thermostat, okay? It's always feeding the thermostat and the solenoid valve. So, I mean, really, that's, if you think about it, that room, if R and black are not closed, it means that the room is not cold, okay? Typically, you know, which is common sense here. Like, why else would this be open if the room is, if it's cold? If the room's cold, like, you know, below freezing, this will be closed, okay? So if the thermostat is set to below freezing temperature, it's gonna freeze up. It's gonna take time for it just to get cold again. So that's why the thermostat's always powered from 4. Okay, so it's always feeding the thermostat. It's always, that's how it's getting cold. Okay, a thermostat and a solenoid valve. So once that thermostat's achieved, the fan's always going to run, but it's going to take the solenoid valve out of the circuit. Okay. Now that was the 240 volt explanation, but you can also explain this the same way with 120 volt. But instead of having L2 going to neutral, it's neutral, it's just a neutral with just 120 volt, okay? So let's, for instance, you know, okay, so defrost solenoid is not able to complete the circuit to travel back to neutral. So once this switch closes, then the neutral is complete. I'm sorry, the circuit's complete, and the defrost solenoid will move this slide bar back to 4. Okay? And that is a basic overview of the time clock and indoor freezer. Okay? This is upside down, but that's just a very basic overview. Hopefully it helped you learn something today. Give me a like and subscribe, and stay tuned for more content. Peace.